We're going to continue with lesson 6.2 representations with using these different examples. So, number one, we have little Plexico who collects Pokemon cards. The collection began with 30 cards from an older sibling. Every Friday, Plexico's father brings a new pack of 5 cards. Complete the table below describing the number of cards Plexico has at the end of each week. Create a graph for a situation. So here we have the graph. W represents the number of weeks. We're going to make a work pattern, and C is going to represent the number of cards. So at the end of 0 weeks, so at the beginning, Plexico has 30 cards. So that's 30 because we're adding 5 times 0. Then we have 30 cards at the end of the first week plus an additional 5. So that's going to be shown as 5 times 1. Well, 30 plus 5 times 1 is, 5 times 1 is 5 plus 30 is 35. Then at the end of 2 weeks, Plexico still has 30 cards plus 5 cards over 2 weeks, which is 10. So 30 plus 10 is 40. Then over 3 weeks, we still have the 30 cards, and then it's 5 times 3. Well, 5 times 3 is 15 plus 30 is 45. So as we can see, there is a pattern for the number of cards, C, where it goes from 30 to 35, 35 to 40, 40 to 45. So they're increasing by 5 every time. So now I'm going to go over to the right and I'm going to graph this. So I'm going to graph 0, 30. If it helps, you could always write the ordered pairs. So we have 0, 30, 135, 240, 345. So my x values I'm getting from over here, and then my y values is the number of cards. All right, so I'm going to graph 0, 30 and plot that. Then I'm going to plot 135. Ooh, well, this is not 135 because that's the number 40. So you have to be careful. It's going to be halfway between. Then it's 240, 345. Well, I could keep going and do at continuing the pattern. 450, 555, 670. And then I'm going to draw a line that's connecting all of my points. So letter A asks, how many cards does he have after 5 weeks? Well, if I look at my graph after 5 weeks, ooh, he's going to have 55 cards. Then letter B says, write an equation to describe this situation. Well, we're going to look at the work pattern. We know that the total number of cards, C, is going to be 30 plus 5 times whatever number of weeks you're on, so 5W. So C equals 30 plus 5W, or C equals 5W plus 30. Both of these are appropriate answers. Using the commutative property of addition, you can add in whichever order, so both of these would work. Number 2, Florence is sick with the flu. Her temperature rises half a degree each hour. At noon, her temperature is 99 degrees Fahrenheit. Complete the table below describing her temperature at each time. Create a graph for the situation. Okay, so we're taking her temperature at noon, which is 99 degrees Fahrenheit. So that means we're starting at 99 degrees and we're adding 5/10 of a degree times 0 because we aren't changing that. Then we want to increase the next hour by 5/10 of a degree. So I'm taking my 99 degrees and I'm adding 5/10, one of those 5/10. So that's going to give me 99.5 degrees. Then I'm going to add another 5/10. Well, this time I'm doing 5/10 and multiplying it by 2. So that's making it 100 degrees. Same idea after 3 hours. 99 plus 5/10 times 3 brings me up to 105/10 degrees. So I'm going to graph these. I have 0, 99, 1, 99 and a half, 2, 100, 3, 100.5, 4, 101, 5, 101.5, 6, 102. Now I'm going to connect my lines. So when is her temperature 102 degrees? Well, 102 degrees is here. So it's this point. So that matches up with 6 hours. So that's 6 hours after noon. So that's going to be 6 p.m. Letter B is asking, what is their temperature at 3 o'clock? So at 3 o'clock, that's 3 hours after noon, her temperature is going to be 100.5. 105 degrees Fahrenheit. Letter C, write an expression to describe this situation. Well, our temperature T is always going to be at least 99 degrees at this point. How much you're adding is dependent on the number of hours. So that's 0 and 5/10 H. So T equals 99 plus 0 and 5/10 H. Or T equals 0 and 5/10 H plus 99. Number 3, Erin has 4 pairs of earrings and buys 3 more pairs every month. Complete the table below describing the number of pairs of earrings that Erin has at the end of each month. Create a graph for the situation. So we have M is the number of months and E is the number of pairs of earrings. So the number of pairs of earrings depends on the number of months. The months is the independent variable. So we know at the end of at the very beginning, she has 4 pairs of earrings. Then after 1 month, she has 7 pairs. And to show that, starting we have 4 plus 0 times 3. Or actually, I'll change that. 3 times 0. Then for month 1, 4 plus 3 times 1. 3 times 1 is 3 plus 4 is 7. After month 2, we still have the 4 pairs plus 3 pairs per month, so there's 2 months. That's 4 plus 6, which is 10. Then at the end of the 3rd month, 4 plus 3 times 3 is 9. 9 plus 4 is 13. And lastly, the 4th month, 4 plus 3 times 4. 3 times 4 is 12 plus 4 is 16. So my ordered pair, 0, 4, 1, 7, 2, 10, 3, 13, and 4, 16. So I'm going to graph those. I have 0, 4, 1, 7, 2, 10, 3, 13, 4, 16. Then I'm going to take my line and I'm going to connect my points. So how many pairs of earrings does she have after 5 months? Oh, well, this is on my graph. After 5 months, that is going to be 19 pairs of earrings. It's located at this point right here. So 19 pairs of earrings. Yes, you want to make sure that you are labeling these. Letter B, How many months does it take Aaron to get 25 pairs of earrings? Hmm. Well, if you notice, the number of pairs of earrings stops at 20. So we're going to have to use some more math knowledge of solving this. So 20 pairs of earrings represents E. So that means that we need to use an equation. So let's first solve letter C and then go back to letter B. Letter C, write an equation to describe the situation. Well, our total number of earrings is equal to 4 plus 3 times the number of months with it, which is M. So E equals 4 plus 3M, or E equals 3M plus 4. So when we get 25 pairs of earrings, that represents our E. So 25 equals 4 plus 3M. I'm going to subtract 4 from both sides. That leaves me 21 equals 3M. Dividing both sides by 3, I'm going to get 7 equals M. So it's going to be 7 months. So for letter B, 7 months. Moving on to moving on to number 4. Chet has 35 Cheerios and eats 5 every minute. Complete the table below describing the number of Cheerios that Chet has at the end of each minute. So let's start with M is the number of minutes, so 0, 1, 2, 3. We're going to figure out a work pattern and then the number of Cheerios that are left. So at 0 minutes, Chet still has 35 Cheerios because we have 35 and we take away 5 per minute. So it's 5 times 0. Now I'm going to take 35 and subtract 5 times 5 minutes. Times 1 minute, which is 30. So after 1 minute, Chet has eaten 5 Cheerios. That leaves only 30. After 2 minutes, that's 5 times 2, which is 10. 35 minus 10 is 25. After 3 minutes, 35 minus 5 times 3. 5 times 3 is 15. 35 minus 15 is 20. We can also check our pattern to make sure that it matches. 35 goes down to 30, down to 25, down to 20. So it's decreasing by 5 every time. That looks perfect. So let's graph this. The number of minutes is my X. Number of Cheerios is my Y. So my ordered pairs are there 0.35, 130, 225, and 320. So 0.35, 130, 225, 320. And I'm just going to continue this pattern until I get down to the bottom, just because it's kind of satisfactory to draw the whole thing. So letter A says, how many minutes does it take Chet to run out of Cheerios? Oh, well, that's going to give you 7 minutes, because that will give you the ordered pair of 7, 0. So that means that you eat all the Cheerios. So it's going to be 7 minutes. Letter B, how many Cheerios does he have after 5 minutes? Well, 5 minutes, he has 10 Cheerios. Letter C, write an equation to describe this situation. Well, we have the number of Cheerios C equals 35 minus 5 times the number of minutes M. So C equals 35 minus 5 times M. Or if you wanted, you could have C equals negative 5M plus 35. If you switch it to the second equation, that's fine. Just keep in mind that the negative remains with a 5M and 35 remains positive.